Taking pictures, make sure you can see no less. That we secure like the money in our safe. I look like big, know I'm on the way. Let you know when I'm about a mile away. When I'm outside, please don't make me wait. The party's starting when we pull up to the gate. Girl, we so late, I'm just with the crew. We ain't out here looking for blue. Cause some nights be better with you. It's a homie, slowly kind of mood. And tonight we are 100. The drop off love, baby, my boss keeping it cute. Ooh, ooh, that's just what I do. And that's just how we do it. Yeah, that's just how we do it. You like it what I do. Know how to keep it cool. And that's just how we do it. Yeah, that's just how we do it. And you can do it too. No complaints. Left the heels at home, I'm on my sneaker game. He said, where you from? I'm out of space. Cause the back the only thing I'm trying to chase. I'm in my head. Just tell the DJ, press the play, rewind, keep it on repeat. Tiptoe around the head, have a light on my feet. That's how you do it, keep sun on your enemies. Good vibes only. We ain't out here looking for blue. Cause some nights be better with you. It's a homie, slowly kind of mood. And tonight we are 100. The drop off the baby, my boss keeping it cute. That's just what I do. And that's just how we do it. Yeah, that's just how we do it. You like it what I do.
Hello and welcome everyone. Thank you so much for joining us. My name is Samara Berger and I am with the Office of Enrollment Management. I am so excited to welcome you to our first Trailblazer session of the season, the Art and Science of Data Science with Dr. Andrea Jones-Roy. Our hope today is that you will get a glimpse into our vibrant academic community and you will see for yourselves why this place has become home for so many folks. We hope that you will leave this session feeling inspired by our talented faculty and really excited about the possibility of joining this rich, diverse community of thinkers, go-getters, change makers. You fill in the blank, the world is your oyster here at NYU. Before we go any further, I do just want to share a couple of housekeeping tips. You will be muted throughout the duration of the session. And while we cannot see you, we do feel your energy out there. So please stick with us. We promise we'll make it good. We will not be covering any admissions or financial aid info today, but if you do have questions about the application process, you can visit our website, give us a call, send us an email, an owl, carrier pigeon, whatever your mode of transport is. And our staff is ready and available to help with your questions and concerns. If you are interested though in asking questions specifically about this session, you can use the Q&A function at the bottom of your screen. And we do have some staff members behind the scenes who are going to flag some questions for live Q&A at the end of our session. So let's get started. I would like to introduce Dr. Jones-Roy. Dr. Andrea Jones-Roy is the Director of Undergraduate Studies and a visiting associate professor at NYU Center for Data Science. Their primary research interests are on using data science to improve the experiences of employees at work in terms of belonging, equity, inclusion, and diversity, and especially with respect to increasing the objectivity of performance evaluations and hiring practices. They're also a stand-up comedian and circus performer and regularly use both to increase public understanding of enthusiasm and social and data science. I promise this is going to be fun. In this webinar, Dr. Jones-Roy will discuss the art and science of data science. So when we think about data science, we tend to think about programming, statistics, and lots of numbers. While that is a big part of it to be sure, and among the most important and often overlooked ingredients in making the most of data are creativity, imagination, and gut instincts. So in this webinar, Dr. Jones-Roy will share why data science is as much an art as it is a science, and why collaboration between more science-minded and art-minded experts is one of the most promising and fun areas for discovery, and how to do more of it. So Dr. Jones-Roy, take it away.
Good morning, good afternoon, good evening. Thank you so much for the introduction. Thank you for having me. Thank you all who are tuning in for being here. I'm super excited to be part of this series. and to be here with you all. As was said in the opening, we are taking questions, so feel free to drop questions via the Q&A. And I also like to do things in an interactive way, lest I sit in my office just shouting at my laptop, which I can do as well. So feel free to drop questions, thoughts. I'll ask you some questions in the chat as well. All right, so this is the NYU Trailblazers series. Here we are. As advertised, we are here to talk about why data science is both a science and an art, and why we need you, whether you're a science-minded person, an art-minded person, somewhere in between. Data science needs all hands on deck. So it's going to sound like a sales pitch, but that's because I believe it. All right. And I am the director of undergraduate studies at the Center for Data Science. So what that means is that if you major or minor in data science, or do a joint major or a double major with data science and something else, you'll deal with me quite a bit. I also teach some courses here at NYU in data science that I'll talk about in a moment. So we don't have a ton of time, so we're going to blaze right through some of my very favorite topics. So we're going to kick off. We're going to talk about why we should all be excited about data science, all of us. We're going to talk about the role of imagination in data science, and we're going to talk about collaboration in data science, and then we'll wrap up very quickly. So to start off, my motivation for the work that I do, whether I'm working with companies or speaking with the public or teaching about data science, and including doing this event today, are threefold. One, data science is super exciting. We're all hearing about it, I'm sure, but I believe we could do so much more with it than we're already doing, and we're already doing some awesome stuff. I also believe that today's most pressing problems, and I don't think I need to list them, they're probably top of mind for you. Today's most pressing global, national, community level, whatever level you want to look at it, problems require all hands on deck. And unfortunately, for the most part, we tend to be working in silos when I believe we need a lot more collaboration and communication. Some of that's changing. I hope to accelerate that change. All right, that's my formal motivation. Here's my secret motivation for why I'm doing this. When I tell people that I'm a data scientist, I get two responses. The first response is, oh, some weather we're having. How about those Red Sox? I shouldn't say Red Sox in New York, right? No one wants to talk to me about data science if they're not already a data scientist. And that's too bad, because data science is something that should be accessible to everyone. But people say, oh, that's not my world. I don't know anything about that. I'm a creative. I couldn't possibly. I don't think that's true. All right. Second is people who do want to get involved in data science say, ooh, data science. What programming language should I learn? Now, that is a fine question, but it's the wrong question to start out with. Asking what programming language should I learn if you're just thinking about starting data science is like saying, ooh, I want to get involved in building houses. What hammer should I buy? Should I buy the Stanley Fatmax smooth face nailing hammer, 5 3/4 inch steel handle? Or should I buy the Stiletto TB15 MC claw hammer, right? Those are fine questions, but that's not where you start, okay? By the way, it's obviously the anti-vibe Fatmax. Okay. So here's what I wish people were asking me, and I hope you will ask me by the end of this presentation. So questions like, wow, how could I lend my expertise in figuring out what to study through a data science lens? How might I get involved in carrying out and evaluating research? Way down the road, we can start to talk about hammers. Okay, so who am I? We got a great introduction, so I'll go quickly. I'm right here beaming in live from the NYU Center for Data Science. I also do a lot of consulting with Fortune Global 500s and tech companies, mostly. And I, here at NYU, in addition to running the undergrad program, I teach a course called Data Science for Everyone, which is our first course in the sequence for the major, and it's open to, you guessed it, everyone. I also teach some upper level courses, largely in natural language processing. All right, and as advertised, I do perform comedy and circus, and I don't normally mention that when I talk about data science, but today we're talking about how art is integrated in every step of data science, so I thought I'd flag my art credentials. Okay. Goals for today. Let's get lots of people and perspectives involved in data science. Let's inspire folks to bring creativity and imagination to scientific questions. And let's encourage interdisciplinary, international, and inter-everything collaboration. If you want, you can clap along to get some collaboration going. Maybe people around you will think you're nuts. Fun. So let's get excited. Buzzword alert. Oh my goodness. When we think about data science, my goodness, do we have different ideas about what it means? Feel free to drop in the chat what you think of when you think of data science. I think each of us probably has a different idea. I'm going to give you my definition, though I am going to be on the lookout for yours. And this is just mine, right? There's lots of ways to think about data science. Data science is better understanding the world through data And who can guess the second word? Oh my gosh. Science. Yes, what a creative definition I have come up with, right? There is programming, and in honor of the new Mac release, here is the 1998 iMac. All right. So there is programming, but we're really talking data and we're really talking science, and programming is a tool to facilitate those, a very important tool, right? So, and why are we doing that? We want to observe trends in the world. We want to explain why something's happening, and we want to predict what's happening next. Hooray. All right. One thing I do when I teach data science is I put this up early on in the course, and I say, when you think of data science, you probably think mostly of programming. Great, that's a big part of it, right? There's also statistics, that's a big part of it. And something that a lot of folks don't think of immediately that we're going to focus on is substantive expertise. And this could be whether you're interested in things like education, literature, psychology, medicine, business. We need folks who are interested in the, quote, real world, right? We need your expertise to help us figure out what to write programs about, what data to even analyze statistically, right? And we all have a role to play, even if you are sitting here thinking, I've never written a computer program in my life, or if you're sitting here thinking, I do nothing but write programs, how do I get involved, right? So let's further break down this data and this science. So data, a lot of folks think is truth. That it's data, it's a number, it must be true. A lot of folks ignore the science side of data science, and they're like, oh, it's just there to sound fancy because saying I study data doesn't feel like enough, right? Okay. One of the things that makes me most upset in this world, well, there's a few things, but one of them is when people say data can speak for itself, or ask the question, what does the data say? Data doesn't say anything. Humans say things about data. And when we do remember the science part, we do have a tendency to falsely think that science means it's correct. And we see that happening in the world all the time right now. Anytime there's a new update about the pandemic, we're like, oh, actually, this might be the case, or maybe we need a third vaccine, or maybe we don't. And people think, well, I thought science was supposed to be right. Science is supposed to be wrong. And then we're supposed to keep iterating so we get hopefully less wrong. Okay, so none of these are correct. And I know what you're thinking. And yes, I do my own graphics. Thank you very much. Okay, so data is not truth. And this is going to tie into creativity, I promise. So data, if it's not true, what is it? Well, it's a momentary approximation, a snapshot of life at a particular time and a particular place. The temperature is 7. The number of people in the room is 9, right? And it's something of a subjective approximation. I, the scientist, have decided what's worth measuring. I'm going to count up the number of people here. I'm going to count up the weather. I'm going to measure happiness or sadness or infection rates, right? I'm deciding what to measure, and I'm deciding how to measure it. Now, this is not the same thing as saying that there's no such thing as a reality out there. And by the way, I think all my references are from before you all were born. Welcome to the late 90s. There we are. All right. So the truth is out there. There's a real temperature out there. There's a real length to the table that I'm sitting at, right? There's a real sense of how happy people are around the world. But I, the scientist, am measuring it with a thermometer or a measuring tape or a survey that I've designed. So you see how my thinking can get involved in data science already. Science is also not correct, right? Science is a series of steps taken over and over and over again, and it's always tentative. We start with questions, and we are humble, and we are open to being wrong. That's the hardest part of science, right? No one likes being wrong. So when we do science, you've probably seen the scientific method elsewhere. Really, it boils down to 3 steps, right? We're going to ask questions about the world. Why is it hot in the summer, right? That's maybe not the greatest question we've thought of, but there you have it. Well, I think it's hot in the summer because of blah, 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 right? Well, if I'm right, then I should see, etc. And you go look for it, and you do it again and again and again, right? And every one of these stages needs curiosity, it needs ideas, and it needs expertise. I have to wonder something about the world. I have to think up, gosh, what could be explaining this thing? And then I need to talk to experts to say, well, how would I measure my hypothesis about why it's hot in the summertime? As said in the introduction, I work with companies a lot. Here's what I see companies do. And we do a lot of work on worker satisfaction at the company. A lot of companies call this engagement. They say, we're obsessed with engagement. We want high engagement levels among our employees. And then they hire me to come in and figure out how engaged everyone is. And they give me millions of spreadsheets with numbers that go forever, right? And then what happens if you're just given a million spreadsheets with no idea what you're looking for, why you're looking for it, what you hope to understand? You start off and say, look at all these numbers, it's so interesting. And then you say, well, this is really a lot of numbers. I don't know where to start. Hang on, why am I looking at these numbers and not these other? Okay, all right, this is enough, right? That gets pretty overwhelming and emotional pretty quickly. All right. Instead, and then you end up with results that aren't so amazing. So you end up with things where, and I've seen companies do this, where they say, well, the high performers are the people who are most engaged. That's a common correlation. And then the conclusion that CEOs will draw is like, I guess the people who are less engaged, who are less happy at work, are just mad about their low performance scores. Maybe, but I bet there's more to it. What if the people who are low performers are less engaged and their performance is lower because they're less engaged, because they're not included, they're not listened to, they're not respected, et cetera, right? Other companies love to say engagement is up. People are happier now than they were the last time we did this survey. Bravo us. Could be, but it could also be that the people who were not engaged were all driven out of the company. That's not necessarily very good. Finally, I see this a lot. Companies say, well, if I look at what correlates highly with engagement, I see that this question about whether or not you feel you belong here at this company is highly correlated with engagement. And so they leap to the conclusion, well, belonging is a driver of engagement. Let's drive up belonging. Driving up belonging is probably a good move no matter what, I think. But they don't necessarily pause to think, actually, some third thing is probably driving both belonging and engagement. Instead, I recommend the old scientific method, right? Start with a question. Why are some employees engaged than others? I don't see companies start with questions. And so that curiosity, that artistic imagination, that why is the world this way? The kind of skills we get in art classes apply here. I can observe something. Well, underrepresented employees are more likely to be less engaged. I could have a theory that it's something to do with a lack of inclusion. It's hard to measure inclusion. So one observable implication of inclusion is someone is talked over in meetings or interrupted. Right? So I could actually go out and sit in meetings and record speaking time. I'd get everyone's consent and do it above board, but I could do it. If I'm correct, the folks who are underrepresented should be interrupted more, or the folks with lower engagement should be interrupted more, and those should be roughly the same people, right? I reject H naught, that's to say I reject the null hypothesis, so I think there is an effect, or I think there is something interesting going on here. The reason I go through all of that is because we're so obsessed with data science, but data only plays a role in 2 of these many steps, right? So let's talk about the other things that we can do. So here's another late 90s reference. Please, in the chat, if you know what the reference is that I'm covering up with the word data, I will give you 10 million points, okay? A lot of times people, when they do data science, think, I have too much data. What am I gonna do with it all? Begin from a place of curiosity. Use theories and hypotheses, and we've got to have that expertise. That's what got us to the idea that it might be inclusion in the first place. All right, so let's talk imagination. How does imagination fit into all of this? Paella, Visme, yes, yes, yes. Seinfeld, Gabriella, yes. Oh, you all, A+. Okay, this is not a graded event. I'm so happy. All right. So how does imagination fit in besides being curious? Well, I said data is not truth, but we turn truth into data via measurement. Measurement is my favorite step of data science. You're not supposed to have favorites, but I do. And here are 3 steps of measurement. There's conceptualization. What do I mean by the thing I care about? How engaged are my employees? What does that actually mean? Does it mean happy? I don't know. What's the meaning of life? How democratic is it a country or a society? How equitable is a country or a society? Those are big abstract questions. What do I mean by that? A lot of companies that I work with care about leadership, and they don't even bother to define it. They say it's kind of like effective or gets things done. Like, okay, right? Step 2, operationalization. This is, how do I turn the thing I care about into a number? So how am I actually going to turn it into data? So leadership gets things done. A lot of companies, unfortunately, say, all right, let's just go around and rate everyone on a scale of 1 to 5 and use that to decide who to promote, right? Not the best. Validation is a very important step, which is, how do I know I measured the right thing? I've got my numbers on a spreadsheet now. How do I know that I actually picked up what I wanted to pick up? Most companies, unfortunately, don't do this step. They kind of just hope for the best. A slightly better idea, and it's not the only one out there, is, well, when I think of leadership, and you can reflect on this, what comes to mind if you think of leadership and you wanted to say, who are the leaders among us, right? What I think of is it inspires and motivates others. Okay, if that's true, then the way I would turn that into a number is to evaluate the growth, the performance, the learning, the abilities of the folks on their team over time. That's a totally different type of data, right? And that's just coming from my thinking about what leadership might mean. Validation, who am I ruling in and ruling out? Now I have my list of leaders. Does that speak to my gut instincts about what counts as a leader? And that's how we do it. There's a lot of data out there on what's the happiest country, right? And we go through these very steps to answer it. Another way that creativity plays a very big role in data science, in addition to measurement, is to test hypotheses themselves. So I am going to share with you one of my favorite research studies, and it takes on a very controversial idea. So the idea is that air pollution might be bad for people. I know it's a wildly controversial claim, but here we go with me. The ideal, the gold standard in science to understand the effect of air pollution on human health would be to randomly assign bad air, polluted air, to some people and non-polluted air to others, and then see what their health looks like. There are a few problems with that. Feel free to drop them in the chat. There are more than the two that I'm listing. Please feel free to list others. I would say a big one that comes to mind for me is ethics. We can't exactly expose a whole bunch of people to polluted air. The second, in distant second, is that would be very expensive. Gabriella, external factors. Exactly. Who knows what else is going on in these folks' lives, in their environments? Exactly. A lot of reasons we can't do that as much as that would really help us understand. So one of my favorite studies took advantage of the fact that something very interesting is going on in China. So in China, and I apologize, this is really loud traffic noise. I wonder if I could stop it. I don't know if I can. All right. In Beijing, I don't know if we have folks zooming in from Beijing, Dajiahao, if you, or anywhere in China, hello. I taught at NYU Shanghai for a while, so I'm a big fan. And in Beijing, there is a rule, or at least there used to be, that to minimize traffic and to minimize pollution, there was a rule where only cars could drive into the city without a fine or something that ended in an odd number, or had license plates that ended in an even number. So something like Monday, Wednesday, Friday, odd numbers, even numbers the other days. A lot of cities do things like this, right? In China, the number 8 is considered very auspicious. And so a lot of folks pay extra or go out of their way to get license plates with 8 in it. So that means that on even days, more cars drive into the city than on odd days. So what we've set up is something called a natural experiment, where we're acting as though there's a treatment and a control. A treatment is less air pollution on odd days because fewer cars, more air pollution on even days because of more cars. That takes a lot of imagination. That takes a lot of local knowledge, right? To know to look for this. And I find it to be so clever. And they did establish indeed that on even days, there were more trips to the hospital in Beijing for lung-related complaints. So this is awesome. Not the findings are depressing, but the study design is awesome and so out of the box, right? All right, last piece, and then we'll go to questions. I think I've already talked too long. It's easy for me to say we need experts and we need programmers and we need statisticians, et cetera, et cetera, et cetera. But it's not so easy for us to actually work together. Now, this is one of those old-timey inspirational posters. It's hard to read this text, so I've rewritten it for you. Teamwork. Super hard if you're not already on the same team. If we're not all trained in crew, we might have a rocky go at trying to get somewhere. The same is true in data science. As valuable as collaboration is, it can be rather tricky. Here are some common myths that I work with companies to try to debunk to help data scientists and folks who aren't trained in data science work together. There's a big misperception out there that data scientists are all young, that they all have the same career goals, that they prefer to be solitary, right? The Mr. Robot style, working with headphones on and speaking to nobody kind of programmer stereotype. A lot of people think data science has anything to do with computers, and that if you're talking to a data scientist and you don't understand what they're saying, that it's your fault and you should panic and run away. Not surprisingly, these are not true. It's never too early or too late to get involved in data science. And I say this as much to any parents who are watching out there as to the students, potential hopeful students. There are tons of different ways you can be a data scientist and show up as a data scientist. You only have to be solitary if you want to be. If you want to be, go for it. Data science, I also don't know why your Wi-Fi isn't working. I can't help you. And this is actually controversial, unlike the air pollution claim, right? If a data scientist shares their work, but nobody understands it, did they even discover anything? A lot of data scientists don't necessarily like this claim, but I believe that if you can't communicate what you've discovered, we really lose the value of that discovery. You don't always have to make it understandable to everybody, but you have to make it understandable to at least someone who can then make it understandable to others. Yeah. And just to leave on a slightly more positive note, here is one of my best, most favorite examples of an amazing collaboration between a data scientist and a substance area expertise. This is a professor at MIT named Regina Barzilay. She spoke at the NYU Text as Data series a few years ago. She puts data in the hands of doctors, and she's held up as a model of how algorithms can benefit humanity. What happened is she, a handful of years ago, was diagnosed with breast cancer herself. She's fine now. Went to Mass General Hospital and they prescribed a treatment plan. And she said, well, how effective has this treatment plan been among your previous patients? And they said, well, I don't really know because we don't track that because it's not digitized. And she thought, that's unfortunate. That's a lot of information. And so, we have data from clinical trials about treatment effectiveness, but we didn't have real life, everyday data about how these things were turning out. So she set aside her fancy algorithms and all this stuff and partnered with her doctor and the team at Mass General to thoughtfully digitize all of these records. And now they have a massive database of treatments and their effects and the outcomes from Mass General. And now it's spreading around the world. Amazing, right? All right. So to summarize, I have said that it's an art and a science. Why is it an art and a science? Well, we need instincts to develop theories. What's going on? What are my instincts around this? We need to use imagination to collect new data. How could I measure leadership? How could I measure happiness? And we need to use creativity to design research. It's not obvious how to test something that seems obvious, like air pollution is bad. We need to be creative about how we could actually go about figuring that out. And look at these animations. We need to work together. After we've started doing all of those things, I am more than happy to talk about hammers with you. And by the way, I like Python and R, but there's a lot of programming languages you could use. All right, I think I've talked for 100 hours. I see some questions have come in, so let's take some questions.
Oh my goodness. Thank you so much, Dr. Jones-Roy. That was fantastic. I would like to audit your class immediately. So let me know when I can do that.
You're welcome to, though I am giving a midterm today, so I wouldn't.
No, I don't want to do the work part. I just want to come to learn the stuff part.
All right, come on in then. Yes.
Okay, perfect. But you are absolutely right. We do have some great questions in the Q&A that I am going to pitch to you.
Fabulous.
So to get us started, coming from Brian, how can we control for uncertainties?
Ooh, thank you, Brian. So we can't. And that's as much an answer in data science as it is in like yoga and meditation. I feel like I actually have a lecture in my data science course where I say, dealing with uncertainty. That's one of the hardest things in data science and science in general. So sometimes there's uncertainty because we can't measure the thing we're interested in exactly right? I write down 12 heartbeats and I should have written 15. And so there's some uncertainty in what the truth is, but there's also uncertainty in what's going to happen. A lot of the predictive models that we have, and think about how we predict the stock market, or we try to predict elections, or we try to predict sports outcomes, right, is based on what just happened. And I don't know about you, but in my experience, what just happened or what happened in the past is not always the best predictor of the future. So we do a few things. One, statistically, we have techniques to say, well, there's a margin of error, or the probability of seeing this outcome is greater than that one, but we can't say this is definitely going to happen. And we can sort of think about that. We can also think about designing research in such a way to hopefully minimize uncertainty. So collect a bigger sample, do the same study 3 different times in 3 different places, but it's still not perfect. Finally, we just need to be smart, thoughtful people. If I do a survey of people here in Washington Square in New York and say, who are you going to vote for in the next in the election in November here in New York? I need to know as a researcher that I'm not necessarily going to pick a representative sample, and that people aren't necessarily going to be honest with me for lots of reasons, right? And so I need to say that there's probably some uncertainty built in even to these numbers, because I'm not necessarily getting the full, or the people say, yeah, I'm going to vote, and they don't even go to vote, right? That's very common. So how do we deal with it? We think about it all the time. That's not a very satisfying answer.
No,
it's a great question.
I think that's awesome, because we have a similar question from Anna, who wants to know, like, how do we know when taking those external factors and uncertainties into account is worth taking into consideration as we're analyzing data?
Ooh, these are such good questions. Well done, everyone. So, as usual, there's a million answers to this. One big one is it's such a common thing anytime we present research in data science, and this is true in any science, is people in the audience will raise their hand, and this might be colleagues, it might be students, it might be industry experts, policymakers, whoever, and say, well, hang on, you're saying, for example, that education is associated with higher income, or having a dog is associated with better health outcomes, et cetera. Well, what about this variable or that variable or this other missing thing, right? It's very common to say, because every study leaves out most of the world, right? We can only look at a few things at a time. The burden of the person pointing out the missing variable is to say, I think you're missing this thing, and I think that's going to affect your results in the following way. And then we say, okay, is that effect likely? And is that effect so large that we should probably incorporate that? So in the dog example, right? People who have dogs are more likely to have better cardiovascular health. And so you might say, oh, it's the dog walking. But what if what we're missing is that people who are already naturally more active are like, I would love to have a dog. That could probably really affect our results. So maybe we need to think about controlling for that, right? Paying attention to that when we do our study early on. But sometimes we say, well, we're missing this variable, but like, I don't really think, people who have big houses or something, you're like, I don't think that really matters. And that's just up to us as scientists thinking about the world. And it's a judgment call at the end of the day.
Yeah, I love that point about your remarks, that it truly is, there is some subjectivity and objectivity there, depending on who the person is that's collecting all of this information. And
Totally.
So taking that into account really is key.
And there's some subjectivity in the fact that I mentioned dogs as opposed to cats, because I like dogs.
Yes.
So
yes. Well,
there's some human bias right there.
Well.
Yeah.
So if we're being honest, I would love to research puppies instead. But you mentioned this kind of in passing, but one of our guests picked up on it. Christian would like to know, how does the stock market use statistics in relation to data science?
That is, I was going to say the $1 million question. That's like the quadrillion dollar question, right? So there's a big arms race is too grim a word for it, but I'll use it anyway. Out there among folks trying to leverage things like data science, and in particular, machine learning, which is basically taking patterns that we've seen and extrapolating what that means for patterns going forward, thinking about uncertainty, thinking about missing variables and unexpected events and things like that. And there's, every variety of hedge fund, investment firm, finance shop, fintech, financial technology focused financial, investing practices are all using data science and statistics in their own way. And one of the big things that they're building is these, I don't know if they can be patented, but their own private algorithms that they believe is better than the other algorithms. And so, I can't think of a financial institution that isn't at least building a simple model to try to do things like predict the stock market. And if you can come in, and I have students every semester who say, I'm going to build a model of the stock market. And I say, that's amazing. Give me a percentage when you, I don't say that, that's not allowed. So the world is your oyster, as was said at the top of the show. You can do this as well.
I would also love to get in on somebody who tracks the stock market. So keep me posted, please.
Yes, will do.
So I think this is an excellent question. And I think something that you've really tried to highlight. Is it possible to learn data science while you are not the best at math?
I'm so very glad that you asked. Yes is the answer. And there's a twofold answer to that, which is, one, you might be better at math than you think. I had a professor in graduate school, it took till I was in graduate school to hear this, who said, no one's bad at math. They just didn't have the right math teacher. And math is a language like any other. And it's not that you had necessarily a bad teacher, it's that maybe they didn't explain it to you in a way that makes intuitive sense for you. But humans have built in to their brains the ability to think mathematically and logically. We might not necessarily do it in the exact same way or in a way that resonates with you in terms of your previous math experience. So you might be better at math than you think. On the other hand, if all the teachers in the world and you're still just like, I don't really love it, right? It's not really for me. It doesn't come naturally to me. That's fine. There's still tons of ways that you can be involved in data science. So math plays a huge role, but if you're like, I appreciate that these results exist and now I want to implement them in my program, you don't need to solve, prove the central limit theorem in order to take advantage of the fact that you can simulate something in your data and come to some interesting conclusions. And so some very simple programming techniques will be enough to take advantage of the mathematical results and tools that we have without you needing to write and build them yourselves, right? And even if programming isn't your favorite thing in the entire world, I am not a natural programmer myself. I use it as a tool to keep going, right? You use the pieces that you need, and you can be really thoughtful about the data. And there's so many areas of the world that are ripe for collaboration with data science, especially if I think about things like public policy, government policy, stuff like that. That's where my mind goes. Education policy, where we could really involve experts to say, this is the data that we need. This is the data that's actually helping us. These are the results that would be useful to know about. That would be so valuable. So even if you don't want to write a single line of programming, you can be a part of it. That said, I bet you can do more programming and more math than you think. And I will also plug my own class, Data Science for Everyone, specifically is for students who've never programmed in their lives and are like, math is not for me. That's specifically who the course is for. And by the end, you're doing it all.
I love that. And I was going to remind folks that that is what you mentioned at the top, that like data science really is for everybody. So if this is something that is of interest to you, like explore it, check it out. You don't know before you take a class whether or not it's going to really continue to spark whatever your academic journey may be.
Yes.
So to continue, we have a couple more questions here. Anne would like to know, in your opinion, does data science target both the inside and outside perspective?
The inside and outside perspective. That's a great question. I think of inside and outside perspective in terms of like in my own mind and outside impacting the world, but maybe you mean something like, well, I'm not sure what you mean. Maybe you mean something like a company trying to understand what's going on within, but also understanding the world outside. And the answer is yes to all of the above, right? So I'll start with the internal in one's own head and external. Most scientific research, and we haven't really talked about this today, but another thing I like to talk about is that scientists are humans. And the reason we study the things that we do usually have something to do with our own lives. A colleague of mine who teaches the advanced topics course with me on reinforcement learning puts it this way, and others have put it this way too, is that all research is me search, in the sense that whatever it is that you're studying is actually motivated by some, not to get all psychotherapy on everyone, is actually motivated by some inherent interest, right? My original research was on censorship in authoritarian governments, and that's because I was obsessed with how the news that we read affects what's in our brains. And so I studied it for purely selfish reasons. So data science is very much an internal exercise in that what you're doing is motivated by something often selfish, no matter what. And internal and external in the sense that here at NYU, we do a lot of research internally to understand, what's working for students, what kinds of departments are helpful, et cetera, and internal policies, as well as how is NYU impacting the community around us? What is the role of us in the broader sense of New York City? We thought about that a lot when we looked at what we still do, COVID rates within the community and affecting the community, that sort of thing.
I think that is an amazing interpretation of that question.
And okay. I feel like I need wind chimes now. Yeah.
Yeah. And I think, again, just shows the fact that we can really use these methodologies in any aspect that we're looking to research and looking to learn more about. So we have time for just a couple of more questions. So if we do not get to your question today, we'll make sure to give you some contact information for us. But I think this is a great question coming from Matilde. And she's curious, or they're curious about how you find a place in data science, how women in STEM are really changing and accommodating the field, and how are they becoming, major players in this future generation of data scientists?
Very good question. Thank you for that. All of these questions are great. This is it's both an exciting and still somewhat depressing area of data science. It is, as with many fields, it can be male dominated, it can be white dominated or majority population dominated, depending on where you are in the world. And that's unfortunate. That said, I see it changing all the time. And I think that it's so important, especially for folks who maybe didn't grow up seeing people who look like them or remind them of themselves, or who represent their community in high-powered data science or broader STEM roles. That's changing over time. And we are recognizing, and part of the reason that I do the work that I do, we are recognizing that we need perspectives of folks from all walks of life in order to build thoughtful data science models and to understand the world. There's no shortage of examples out there of things like machine learning algorithms, like Amazon sorting through resumes in a way that ultimately ends up biased because they start picking resumes that just have names similar to the CEO, okay? Or algorithms that are biased or doing weird things to us on YouTube or social media or whatever, right? And so there's an increased awareness that one of the biggest ways that we can combat the weird, outcomes that we're getting from these algorithms is to involve more diverse perspectives early on. So in addition to the fact that I believe genuinely that all folks are capable of being, powerful players in data science, regardless of your technical or non-technical background, in particular, data science will be a more effective field if we have folks who can say, well, in this community, this is not how this works, or actually this particular thing is completely missing another really important piece of the story. And so we're just going to have more effective science as we get more voices involved. On a practical level, there is a long way to go, but we do try to, build up communities and support one another if we are members of minority groups here in data science.
I think that is so important. And I think that's something that is very clearly championed in your research. And something that is very clearly championed here at NYU, the diverse perspectives and the diversity of thought is really something that we seek in our students and our faculty. So for our last question, as we kind of wrap up here, for our future data scientists, or don't know that they are future data scientists yet, what is some advice that you have for folks to kind of continue to investigate this field? How can they go about doing that? And if they come to NYU, what are some ways that they can start to get involved?
Sure. So very good question. I'll start with the NYU case, because as you were saying it, I was like, well, step one, come here. Now, this is a true sales pitch. All right, I'm done with the sales pitch. If you come to NYU, you can, of course, take data science for everyone. We offer it every semester and during the summers, but the semester is okay, never mind, is what most people do. And that's okay. If you never take another data science class after that, I'll be personally a bit sad, but that's very common. Right? What we hope is to trick you, right? And say, oh, no, not trick you, but have you say, oh, I love this and I'm better at it than I thought I would be. And at least go for the data science minor, which is only a handful of classes after that, and pairs beautifully with literally any major in the entire world. That's one of my favorite things about data science is that you can pair it with any field. We have people who are in, piano and data, like awesome, right? We also have a data science club, which is entirely student run. And I believe you do not need to be a data science major or minor to be a part of it. You can just, they have a Slack group and they have events. I think they're doing a social event at the end of this week, a game night or something like that. They do datathons where they get in teams and work on data science projects over a weekend, things like that. And that's just a fun way to hang out with folks who are interested in data science. And we have some other groups here like women in data science and a variety of others. So that's at NYU. But for you all, right now, you can start doing data science, and here is how. Think about something that you're interested in, go on the internet, and look for data about that thing. The first thing you're probably going to find is that the data you specifically want doesn't quite exist. There's probably something a little bit similar, but not exactly what you want. And already you can say, oh, what would be really helpful? And just sketch out an idea of the type of data that would be really useful. Or start with the data you can find, even if it's not exactly what you're looking for, download it and literally look at it and get comfortable with the idea of the fact that we've got these columns, we've got these rows, what do they mean? And then look at the documentation that says, here's how we measure this, here's how it came up, and here's like the shortcomings of this data. From there, there's lots of online resources about, statistical thinking and reasoning, but I would start with anything that's very scientific method forward, as opposed to saying, am I going to write hello world in Python? Two great places to go to start just looking at data and getting comfortable with it. There's a website called Our World in Data, and there's a lot of really nice, kind of very simple visualizations of things like urbanization rates over time and child education rates, and it's just global, interesting stuff. Our World in Data. And another one that I talk about a lot is, I think it's called the World Happiness Report, and it is an annual data set about how happy different countries are. And you can also evaluate, well, how did they measure happiness? And it's not perfect, but it's not bad. And they have some new stuff on the effect of COVID on happiness, which, spoiler alert, not great. So go through, get comfortable with actual data, and then just look up data scientists you think are interesting and see what they're up to.
Thank you so much. That was amazing. I'm going to go look up the World Happiness Report because I think that
Yeah.
is an awesome resource.
Yeah, it's super fun.
But again, a huge thank you to Dr. Jones-Boy for a wonderful session, a wonderful kickoff to our Trailblazer series. Thank you so much to our audience for being so engaged. If we were not able to get to your questions today, please make sure you reach out to us. You can check out our data science department by Googling NYU Data Science. If you have questions specifically about the admissions process, we encourage you to reach out to us at admissions@nyu.edu. If you're interested specifically in NYU Abu Dhabi, you can reach out to us at nyuad.admissions@nyu.edu. And lastly, if you're interested specifically in NYU Shanghai, you can reach out to us at shanghai.admissions@nyu.edu. So we encourage you to please check out other virtual offerings and in-person things that we have going on here at NYU. I'm going to drop the link in the chat for y'all. And our next Trailblazer session is actually Monday, November 8th. So please, we hope that you will join us. And with that, we wish you a wonderful rest of your day. Thank you so much for taking the time to be with us. And we look forward to welcoming you on campus very soon. Bye, everyone.